Hi, I'm Drew from Brazen Wolf. Many of you guys have asked me how do I do things, why do I do what I do. Things like how do you weld aluminium without a spool gun, how do you weld aluminium without a push-pull gun, and a few other things. So I've decided to do a build series on a job that we've got coming up, which is a full aluminium trailer build. This one's going to be a little bit different to my past aluminium trailers, similar chassis. And I thought I'll take you guys along with me while I build it and explain why I do what I do, how do I build it. So if we have a look, here is a photo of our last trailer that we've built. We'll zoom in on this one. Hitch, full aluminium. It has a steel subframe for the suspension, but basically full aluminium chassis. We'll find another photo of this for you. Back photo. This is a sign writing for the customer I made it for. It's one of our customers. This trailer was built to carry a 1.7 ton excavator that he has. So we put some sign writing on the back for him that we did on our CNC router. So basically, we're going to copy the same sort of setup, same sizing, same structural channel that we're using on the sides, same axle group. This is a 3 ton capacity. The ATM mass on the trailer is 560 kilos. So that's how much the trailer itself weighs with the ramps and the attachment holders at the front here, and the fuel holder and the spare tyre and stuff like that. So the design's very similar on how we're going to do it. Our new customer is Flagstone Blokes. They want to build a barbecue trailer. So this trailer will be slightly different to this because it's going to be fully enclosed trailer. It's going to have some doors on the sides, doors on the back, a roof rack on the top. It's going to slide out drawers. We'll have a water tank underneath. We'll have a barbecue slide out drawer, sink slide out drawer. They'll be able to put the tables and chairs inside. They'll have a battery setup. So basically, where they've been given the grant by the local council to set up a barbecue trailer for their fundraising, and we get the job to build the structure. So we're not doing the full fit out, but we'll be doing the chassis, the framework, and the skin on the sides. But before we can build that, we need to sort of design. So before we get too many comments on aluminium versus steel, I'll try and explain a few things. Steel trailers versus aluminium trailers. Everyone's going to say aluminium trailers crack. Yeah, aluminium trailers do crack. The aluminium chassis are renowned for cracking if they're done wrong. The pros and cons between steel and aluminium. Well, steel is heavy, aluminium is light. With steel, you can use thinner section. Aluminium, you've got to use thicker section to get the same strength as steel. So steel is traditionally stronger than aluminium, but you need to beef up the aluminium structure to get the same strength. But aluminium will still be lighter than steel. So to do a steel trailer like this, it will probably be 30% heavier than an aluminium trailer, which means your payload, what you can carry, is a lot less than what you can do with aluminium. Cracking of aluminium chassis and trailers. If you build an aluminium trailer the same as you build a steel trailer, they will break. There's no way around it. If you apply what you know on steel and you build it in aluminium, it will break. It's just how it is. Both steel and aluminium fatigue, and they crack after fatigue, so they basically work harden themselves until the metal becomes brittle. It's more common in aluminium because it's more flexible than steel. So before we build an aluminium trailer, we've got to understand why the trailer breaks. So when we design the trailer, we can design it so it won't break. So forget how you build it in steel. So forget the idea of doing that. We need to look at how we build what we build in aluminium and how we can prevent it from cracking. Now, how do we transfer load? Normally when the trailer's driving down the road, it's bouncing up and down, you've got weight on the top, and the weight forces shock vertically through the trailer. So same thing goes to steel trailers. Most people don't like doing a vertical weld on the trailer because a vertical weld on the trailer creates a weak point. Every time you weld something, it changes the structure of the metal and actually makes it weaker next to the weld. So if you see here on the plates, we have diagonally weld. That's so there's no vertical up and down welds. But when we go to the structure underneath, there has to be vertical members under there. How do we stop the vertical load from cracking? So if we zoom in over here, this is a little secret that most people don't realize. So when we put an internal gusset in, we radius inside the gusset. So if you don't radius inside and you just do it square, when the load comes down, and then there's a square edge here, it will transfer shock vertically down, and then that will create a crack. by radiusing the inside corner, transfers the load down and along horizontal. So as the weight comes down and the shock comes down here, it comes down and it transfers that load horizontal on the trailer. So that prevents from having a crack on the gusset. Same goes when you've got these sort of things. They're not vertically down, so it transfers the shock side to side. But it's very important when we have a look inside this trailer that all these gussets have got a radius. That's why I build a trailer with a radius. After years and years and years of building petrol tankers, aluminium trailers are good if they're built properly. So if aluminium trailers weren't any good, people wouldn't build petrol tankers out of them because people would die. Now, there's a few other things going on under this trailer that you don't get to see, but in this build series you will get to see. Okay, so basically we take our design that the customer's drawn up and we try and understand. So this is the paper design. And the customer's gone to great length to try and design to fit what they need to fit. So this one is the size of the trailer and the doors. They want to put some shelving units inside and a roof rack on top, internal framework on the sides where things have to go. And the overall, the main one we're looking at the moment is their floor plan. Because before we build a trailer, even though we're not putting the boxes inside or anything like that, we need to know where all this infrastructure has to land to make sure we build our trailer skeleton chassis accordingly to pick up all our features that we need to do later on. So I sit down and decipher all these plans and trying to figure out where everything goes. Come up with a CAD drawing of our trailer. Same as this. Now, I've got certain heights between the trailer chassis deck to the ground and how we do our axle group assembly, how we set up our axle. Also, the hitch area here is slightly modified from this one to do with the tow vehicle and the height of the ground that we need to do. So we'll go through that in the workshop. As you can see in here, it's got a breakaway, battery breakaway in case the trailer comes off. We set all that up in the fabrication side of things. But basically, we will start with our plan. So this is our basic drawing. This will be the structural C-channel component of the job. So we'll have a back section, which is the same as this back section here, and our front section through here, which is the same as what's under here. Our section cross member here, which is this cross member here, and then we'll add our key features. So in the chassis where we want to put certain things. So we need to have outriggers on the side because it's going to pick up a wall on the external. So there'll be a door here, there's a door here, and there's a door here. Our wheels go in there, and there's just some framework underneath. We're going to put a water tank in here. This is our water tank area. This is a drawer for a sink. Right? As you can see here, I need to put an oval shaped hole for water because I've got to put a hole in the side of the chassis for the water pipes to come through to get around. We'll draw our hitch. Our hitch is going to line up with the bolt holes to attach the hitch. Put our wheels in. This is our wheel 1, wheel 2, wheel 3, wheel 4. Position to make sure the wheel's clear. I'm going to put a spare tyre on the chassis, laying down flat. We need to put some holes. This is the side of the design on the side. We need to put some uprights for the sides of the walls where they're coming up vertically. This is looking down on the top. Some measurements, key things that we need to know where the chassis is going to go. Our mounts. So that's our complete drawing. It's pretty cluttered. So we're going to have a battery over here, it's a water tank under the chassis, drawer here, there's another drawer here, there's going to be a gas bottle there, a gas bottle there. This section here in that drawer is going to have a barbecue, spare tyre here, we're going to have aluminium checker plate floor here at the front, there's going to be a step on the side, so there's going to be a step here, so that's the shape of my step, that's the shape of my floor. So there'll be a step on the side, step on here, we'll have a little ladder here to go up to the top to have a roof rack, so they can get on the sides. For now, we'll just work on base chassis design so we can start making some things. So we'll get back to a base design. So these sections through here, 100 by 50 millimeter aluminium extrusion box section through here under the floor, and these are put in positions to be able to pick up the draw run slides that run on top of them and any internal partition walls that's going to be inside. Our water tank's going to fit in this section, and this is structural channel on the outside. So if we get rid of our dimensions, that's basically what we're going to be building. So now we have all that designed and worked out. We'll send that out to fabrication and we'll get making.